All right, I'll go ahead and get started. Good morning again. My name's John Mullins, and you're attending a webinar today titled Troubleshooting or PL SQL. We're going to be using the DBMS profiler and the DBMS utility packages, or at least some of the programs within those packages. So today we'll look at what our objectives are here in just a few moments. A couple things as we get started here. All right, if you have any questions in your dashboard, there's a question tab over there. So if you have any questions throughout the webinar, feel free to click on that question and enter the question. I'll try to get to as many questions as I can during the webinar, but if you have any questions that either come up after the webinar or later on down the road, you should be able to see on this slide right here, there's my email address. So it's just jmullins@themisinc.com. So feel free to send me an email. That's really the best way for me to get to all the questions. I'll get back to everybody who sends me an email. So send me an email if you have any questions about any of the subject matter from today. Also, a couple other things that you'll see on that slide there. I notice our web address there at themisinc.com, so you can go out there and find any of the course offerings that we have, or telephone numbers, or how to get a hold of us later down the road. And then for after this webinar today, there'll be a copy of the slides that I'll be going through today. Plus there'll also be a recording that you can also listen to and watch later down the road. So if you go to themisinc.com/webinars, you can also get a copy of the slides, which are out there now, and then there's also will be the recording of today's presentation will show up there as well. It's not obviously not out there quite yet. All right, so hopefully everybody's having a good, let's see, we're at Thursday already, right? So everybody's having a good week this week so far. And we're almost to the weekend. So let's go ahead and dive into this. I know everybody's very busy, so let's go ahead and jump in here. So a little bit about, I see some of the names of the attendees, and I recognize some of those names from some of the classes that I've taught in the past. So welcome back to those people, and welcome to the people that I haven't seen before. For those that aren't familiar with who I am, you should be able to see that on the screen there. Again, my name is John Mullins from Themis. I'm coming to you today from South Central Texas, where it's going to be a lovely fall day today, nice and sunny. Yesterday was 87 degrees here and set new records. Today is much cooler. A little cold front come through last night, so we're going to be closer to 70 degrees today here, but it still looks nice out. As far as my background experience, so you kind of know where I'm coming from during this presentation. I've been using Oracle for a little over 30 years, so started back in the 1980s. With Oracle version 5.122 was the first version that I used, and it was actually on a DEC Ultrix system. Don't run across those anymore. I worked at Boeing for 10 years as a developer, programmer, DBA, and then have worked for various consulting companies and training companies since then. I am an Oracle Certified Professional DBA. Those of you that have been in my classes know that, so if you have any questions about certification stuff, feel free to send me an email on that too. And I am also a certified technical trainer. Over the years, those 30 plus years or whatever, I've taught well over 200 classes, approaching 300 classes now along the way there. So again, if you have any questions, make sure you send me an email at jmullins@themisinc.com. Right, I'm representing Themis. Themis has been around for a long time. Many of you, I recognize the names there, have taken classes from Themis before. So you know that we offer all kinds of different classes out there. In addition to Oracle, DB2 type classes, SQL Server, Unix, Linux, Java, and quite a big list there. So you can go out to themisinc.com and get that list from us. And there'll also be a list of classes, course topics, outlines, things like that too. All right, let's jump into here then, so you guys can get on with your day then. The topic today is looking at PL SQL code and kind of helping us troubleshoot it, two different ways. One is from a performance standpoint, and one is from an error or exception type standpoint. So we'll be taking a look at both of those using a couple of packages and programs within those packages. But related to those is we have a really good class that's troubleshooting, debugging, and tuning Oracle PL/SQL programs. Today's webinar is kind of a subset of that particular class there. So I encourage you, if you have further interest in troubleshooting and debugging and tuning your PL/SQL, to look into that class there. If you're still fairly new to PL/SQL, there is an introduction to PL/SQL class and an advanced PL/SQL class as well. The troubleshooting focuses just on that itself. The advanced PL/SQL will look at some other techniques and coding things that you can do to make your code better. All right, today what we're going to look at the DBMS Profiler and DBMS utility packages and some of the programs within them. I'm going to show you some examples of code throughout today's webinar and show you how these two packages and their programs can be utilized to kind of help you, troubleshoot either a tuning performance problem, or it could be just you're getting an error along the way. So we'll use the packages for both those two things, and they're really, if you haven't used them before, what you'll find out is they're really very simple to use. So we'll go through what the steps are. If there's some steps to set them up, we'll go through those. And then once we do that, we'll see how to actually use it, and then we'll see what kind of things can we look at that might give us a clue as to what the problem is as well. All right, we're going to look at the profiler first. Okay, so this one's related to performance. So we're going to use the DBMS utility to look at errors and exceptions and problems that might cause our program to actually terminate. But what if our program doesn't actually, may not even finish, right? You've all probably had or heard of stories of PL/SQL programs, store procedures, or whatever that have run for hours upon hours, and everybody over the course of some time of their career seems to run at least that one time or more. But we have these programs that might run for a considerable period of time. And the problem we run into is we're not quite sure, especially if we have a fairly large store procedure or anonymous block of code, we're not quite sure which piece of code is causing the program to run for such a long period of time, especially if our program calls other programs. So that'll be one of the examples that we'll look at here, is especially with the DBMS utility. If I have a program that calls a program, might call another program, might call a function, and the program I ran from, we're not talking about small programs here. We're talking about programs that have hundreds or thousands of lines of code in them. And yeah, I know the program takes 2 hours to run, but what caused it to run for 2 hours? Was it one particular line of code? Was it an SQL statement, a select, an update? What was it? Was it just a series of statements, just accumulative, have added up to that 2 hour window? How's that 2 hours broken down? And that's what the profiler can kind of tell us here. I really like using the profiler. It's really very simple to use. It has a one-time setup. I'll show you what those steps are here in just a second. But you can see some of the information on this slide here that it'll give you. It'll tell you the total number of times each line has been executed. So, based on, you can see every line of code in your program or programs that are running in this profiler session. And then for each line, we can see who's consuming the most time. And that'll then allow us to, from that point, to focus more on those particular statements. Hopefully there's something that'll stick out, that'll really stand out, that'll tell us, hey, here's the problem out there. All right, so this is give us some really good information for that. All right, like I said, the timings that it shows in one of the reports will let you kind of identify, okay, here's the problem. This particular statement, maybe a select or an update or whatever, a delete, took 80% of the program time. Okay, now I can start focusing and drilling down a little bit further and seeing why that might be the case. If it's maybe a select statement, I could run it through the explain plan utility. I could run it through the SQL tuning advisor. I just need to look at it further. I could investigate what indexes are out there, if my statistics are up to date and accurate. Like I said, investigate the explain plan. Did it do any joins? What kind of joins did it do? Did it do a nested loop join? Did it do a sort merge join? Did it do a hash join? Which one was more appropriate for this particular one? So I can drill down a little bit further. So this is going to help us identify those statements that we can go after. All right, within the DBMS Profiler package, for this particular webinar, we're just going to look at, there's not very many programs in the package. There's one to start the profiler. Once we start a profiling, it's by session to start with. So we start a profiling session, and we're going to use a program called Start Profiler for that. And then we do our work, and you'll see those steps here in a second. And then there's another program called Stop Profiler. There's some other programs in that package. For example, one of them is called flush_data. Flush_data. What happens once we've turned on the profiler and we start to run our code that we're trying to capture information about, it's actually writing the information that it's capturing into memory, okay, on the database server. And once that, we either do a stop profile or we do that flush data program. And that flush data program it's overloaded in the package. You can either run a function or a procedure to execute it. Once we do that, then that information will come down to a series of tables that we could then query and see information about. So there's not much overhead with doing this because it is writing to memory. Okay, and then again, it'll get flushed down when we do the stop profiler or when we do the flush data program. Either one of those will handle that for us. All right, here's the setup that we need to do. And this is just a one-time thing. It only has to be done once. And typically the DBA would set this up, and it'll be set up for everybody once it's set up. It's not, when the database is initially created, it's not created as part of an initial database creation, even if you're using some of Oracle's utilities like the Database Configuration Assistant or such. So there's a script that comes with the Oracle software called profload.sql. Okay, and that's on the server, the database server where the Oracle software is installed. It's in a directory location for the Oracle Home Software /rdbms/admin, and the DBAs will know where that is. It's going to create some objects out there. It's going to grant the necessary privileges for people to use those. It'll create some synonyms, so you don't need to worry about who the owner of the objects are. They'll create some public synonyms out there. This particular script has to be executed as a sys or sysdba type user. That's why a DBA will typically be the one that runs it. So this just needs to be done one time, and then it's set up, it's enabled, it's ready to go. And the script just takes a matter of seconds to run. There's not much that it actually does. Now, once that's done, then here's the important part. There's a second script called proftab.sql. This is going to create 3 tables. And we can either do this one of 2 different ways. And Oracle kind of recommends that for every user that's going to be doing a profiling session, they have their own set of tables. But you could set it up also such that it's just one series of tables that everybody shares. So if we go through the necessary steps here, whoever is going to be doing the profiling, it could be you, it could be a DBA. It does not have to be a DBA. Okay, we just need these tables to be out there. So it creates some tables, it creates some sequences, it puts some comments out there as well. Again, it runs in a matter of seconds. There's only 3 tables it creates. And who we want to execute this script and create these tables will just be, whoever's going to run the profiling session. In other words, who's going to be running the application code, the session that will have the code running in it, in other words. So this will typically be a non-DBA, but it could be a DBA as well. Okay, so we run this. You could run this script once for every user, different Oracle user that wants to do some profiling, or like I said, you could just run this once, and then once we create it once, then the DBA would have to grant access to these tables to public or to certain users out on the system, create some more public synonyms, and then everybody could share the tables. So these tables could either be on a per user basis, or they could be created once and shared with everybody. It's really up to whoever's responsible for your environment there. Again, a one-time thing. Create the enable with the prof load, and then create the tables, and now you're ready to do your steps here. All right, here's your steps. We're going to start the profiler, so we're just going to run that start profiler procedure. So in your session, or in your script, if you have a script that's running, you're just going to go out there and execute the dbms underscore profiler dot start underscore profiler. That'll start your profiling session. And then you just run your application code. It might be a query, it might be a script, it might be a call to a stored procedure, which calls other programs, whatever. Just let your application stuff do its thing. And then when that gets done, or you feel like you've executed a good enough kind of workload, then you'll stop the profiler. So then you can say execute dbms underscore profiler dot stop underscore profiler. It's as simple as that. You run the start profiler program, run your code, run the stop profiler. Now once you do the stop profiler, all the information that's been gathered up in memory up on the server is now going to be written down to those set of tables that were created in the prof tab script. Okay, steps are very simple. Remember, you can get a copy of these slides so you can see the steps and the script names and everything else out at themisinc.com/webinars. All right, here's the tables that are created. We're going to look at two of them in particular today. So PL/SQL profiler runs. That's kind of a high-level view, and you'll see some results of a query that I'm going to have here in just a second. It shows you every profiler session that gets started and stopped gets a run number. So it'll show you those runs that you have out on the system in those tables that you have access to. You can give your run a name, so a comment or such, and then the overall time. There's not too many columns in these tables either, which makes it real nice to do also. The big one will be the PL/SQL profiler data. That's where we can take line by line and find out how long did it take to execute each line of code within that application that we are running in this profiler session. So that'll be an important one. We'll see an example of that here in just a second. And then the PL/SQL profiler units really doesn't come into play unless you've got programs calling programs. A unit is just a program. So if you have a procedure that calls a function, that calls a procedure, each one of those would be a separate unit. So you could see that I spent this amount of time in this program, and this amount of time in this function, and this amount of time in a different program. So you can, again, kind of drill down as to where the problem might be there. Okay, so we'll take a look at each one of those. Okay, so remember, we've started the profiler, we ran our application stuff, and now we've stopped the profiler, and now we're ready to analyze the results. Okay, so here's the first one here. And again, here's our view, or our table, I should say. In this case, I'll put a little arrow there so you can see it there. But we're looking at the PL/SQL profiler runs here. So I'm looking at the run ID, who is the owner of that profiler session, what was the date that it was run. This is the total time of that particular session. So from the start to the stop, this is the total time that's out there. And you can see that the unit of measure it's in, I've here had to divide it so I can get it down here in seconds. And then if there's any particular comment that was there when we started this profiler. So again, I'm just querying from PL/SQL underscore profiler runs. this just gives me a high level view. I can see here, if you look down here at the bottom, that this particular profiler run took 70 seconds. All right, this isn't really steering me one way or another as to what the problem is, but it is telling me at a high level view how long it took. You all, for those of you that have been doing this for a while, you know that, especially if you're a support type person, I work as a DBA a lot, and people will come to me and they'll say, hey John, I ran this thing yesterday and it took like, I don't know, it took like an hour and a half to run. And then when we actually go out and look at the data, like from PL/SQL profiler runs, if we do a profile on it, it may have only taken 30 minutes, but it sure seemed like an hour and a half. We run into that a lot. It always seems like it runs a lot longer than it actually does, in other words. So this will tell us at least how long did it take there, and then we can kind of go from there. So this is just a high-level view. PL SQL Profiler runs there. All right, here's where we're going to get the bulk of our information. If we go to PL SQL Profiler data, all right, you can see up here in the from clause, let me get an arrow on this here for you. We're looking at the PL SQL _profiler data table, and I'm going to join that to the PL SQL Profiler runs. So I'm going to join those together there. And I'm also going to bring in here the user _source. And a lot of you are going to be familiar with this, but this is a view, the user _source. There's also what? An all _source. So user _source, for those of you that aren't familiar with that, that's a data dictionary view. That'll show you the source code for any programs, store procedures, functions, packages, triggers, whatever. The source code for any of those types of programs that you're the owner of, you're the creator of. Okay, if you're not the owner, you're not creator, then instead of using user _source, you're going to use all _source. All _source shows you program source code that you're not only that you're the owner or creator of, but also other people's code that you have access to. So you may need to adjust that to all _source there, depending on whether or not you're the owner of the programs that are being profiled or not. So I'm just doing a little we'll call it 3-table join there. We're looking at here, I want everything other than line number 1. Line number 1 is just a header, so I'm just throwing that out here. And I'm ordering it by line number. Okay, so I'm getting the text. If you look up here at the top, I'm getting the text. That's coming from the user _source. Okay, and then here's this next one's a real good statistic that's coming from the profiler data. How many, the text is line by line of the program that's being executed. So the total occurrences is how often was that line executed? Did we just run this line of code once? Maybe it's inside a loop and it ran 1,000 times. So how many times did it happen, and then how much time did it take as well? And then I'm just showing the line number also. Okay, so this little piece of code is a real good query for querying that PL SQL Profiler data table. Now, if we want to look at the results, I think you'll like, if you haven't seen these results before, I think you're going to like this a lot. So here's the type of result you'll get from that query. All right, take a look at that there. So I'm getting the ... just there's more lines of code up there. I couldn't show all of it on this particular screen. So I got lines of code, lines of code, lines of code. You can I sorted them by line number over here on the far right. So you can see how they're coming in that way. But notice down here, if we look at the total time, there's one particular line of code that looks like, if this is everything, looks like it took up a considerable amount of time compared to everything else. Remember the total, this is the same program that we saw on the previous slide there. The total time of this program was around 70 seconds. And this particular line took 57 out of the 70 seconds. So this will be a good place for me to drill down. I can look over here on the far left and see that this particular line was an update statement. Okay, it's line number 26, okay, and it's an update statement. You can see that that particular line was also executed 50,000 times. So it looks like it's inside a loop. Okay, and then you can see the other lines of code in here too. Here's an insert up here, here's a delete, and there may have been a select up here at the top. That we can't see here because I've dotted those out. But again, that's what I'm looking for here is those lines of code that took up, a considerable amount of time. And then from there, I drill down and I try to tune it from there. So in other words, I might take this line, okay, what are all the things that could cause an update statement to run slow? Well, there could be locking going on. I might be waiting on a lock to be released. There could be contention for some of the database objects like redo logs, log buffers in memory, those types of things, the database buffer cache. It could be waiting on a checkpoint to complete. There's a whole big list that could cause anything from an insert, update, or delete to kind of run slow, other than the fact that we actually executed it 50,000 times too. One of the other things that we would also look at this point in time is there a better way to write that code? For those of you who have taken like the advanced PL/SQL class from us in the past, you know that we could do things like maybe bulk binding. So instead of doing, if this updates inside a loop, and it looks like it sure is right here, instead of doing that update 50,000 times, we could load everything in bulk into an array and just run it one time. And we will see considerable difference in performance if we do that. So if you haven't done that before, after this particular webinar, you can go out there and look up bulk binding in Oracle. We also had a webinar on bulk binding in the past as well. So if you go out to that themisinc.com/webinars, I believe it should still be out there. You could find a webinar out there on bulk binding as well. And plus, that's also in our advanced PL/SQL classes. So this is a little bit on how to use the PL/SQL profiler. You can see it was pretty simple to do, right? Just to kind of recap what we did there. We set it up once with the profiler load.sql script. That enables the feature. Then we ran the prof tab script to put out the tables either for one or more users. And then we're ready to go. Then we did the start profiler procedure from the package. We executed our code, we did the stop profiler, and then we queried the tables. So that's one way we could use the DBMS profiler package and its programs for us to try to troubleshoot a performance problem. All right, you guys are doing great out there. There was a question about the DBMS profiler package itself and what I need to do to be able to use it as far as privileges and such go there. So remember that the prof load.sql has to be run as a sys or sysdba type user. And that does the necessary grants to get everybody the privileges they need to actually then run the package or its programs within the package there as well. All right, let's take a look at the DBMS utility package, and then we'll get you on your way here. So there's a few more programs within this package. We're going to take a look at pretty much all these here just real quick. I've got them all together in one example this time. So we're going to look at some programs within this package. This is kind of a package. It has kind of a miscellaneous or varying programs. They're all kind of there to kind of help you troubleshoot problems that might come up in your program. So there's a function called format call stack, format error backtrace, format error stack, and we're talking about up through 11G on these. Some of these will be changed slightly in 12C. So for example, the format call stack in 12C, there's a program called UTL_call stack. So if your guys are already doing 12C stuff, which a lot of people are now finally getting into it because 12C is still in release 1 for most people. But when you get to 12C, there's a UTL_call stack instead of a format call stack. But it has kind of the same functionality there. So we have the format call stack out there. So we can take a look at that. We'll see what that does. So that's going to give us kind of a trail if you have programs calling programs. And they could be anonymous blocks as well that call, and you'll see that in the example that I run. That's going to give us a trail of, what called what and in what order as well. Because a lot of times we're going to assume that, oh, this program calls that one, and then if this is true, it does this, and if that's true, it does that. Well, based on what I input, I think it should have went through this path this way, but now if we look at the call stack, we might actually find out that it did something different there. Okay. Okay, so that's what the call stack does. It gives us kind of a trail of stuff. The format error backtrace and the format error stack are going to give us information about any exceptions or errors that actually happened as well. Okay. I was just looking at one of the questions in the box there. There's a question about comparing a QA environment to a production environment, and with the profiler before we move on here to the utility one here. So the question was, just looking at there, assume that a long-running program in QA will be long-running in production as well. It depends on, how much alike your QA and production environments are. You know, we can make that assumption that, but again, if you're a lot of times the QA environment will be, you know, a copy of your production environment if it's not too large, and you're able to house that and all the data that's involved there. So you could assume that that's the same problem, depending on how much they are either alike or different. Absolutely. So yeah, you don't have to necessarily run these. If you're trying to tune a production problem, you might go back into your QA environment and run the profiler there to try to figure out what the problem is, and then apply your solution to production. Absolutely. That's a good question. All right, and then we'll look at get CPU time and get time. Maybe a lot of you have been using those as well. So those are just functions within this package. They're going to return a number that's in hundredths of a second. All right, and I'm going to show you an example of how to do those also in just a second. So let's take a look at the DBMS utility package on some of these programs here. All right, I've got a series of 3 procedures here. So take a look at each one of these. Let me go back here, get the right page for you. There we go. Get my arrow going here. So this first one here is just called Proc3A, and you should be able to see that up there on your screen, just procedure 3. Procedure 3 just calls a procedure called Proc2A. That's all it does. So I'm going to execute this program first. And notice here in my exception section, I've got a call to the air stack, I've got a call to the air backtrace, and I got a call to the call stack. So it's pretty common from one place to another, and you guys might be doing this, or maybe not. Maybe you've seen it in some other code that you're not responsible for. But down here in your exception section, you're going to be handling any exceptions, both user-defined and also predefined, that may come up. And so you're going to have very specific exception handling going on there, but then you're probably going to end it with a when others at the bottom of your exception section. So it's always kind of good down in your when others to maybe include maybe a call to all 3 of these, and I like to do all 3 of those in my when others at the bottom. In addition, I might put some other stuff in here too, like inserting some records into a log table, or writing out to a log file, or just calling a general log procedure, or whatever that might be too. So let's take a look at this program here real quick. This is procedure 3. All it does is call procedure 2. I'm just trying to set up an example here. All right, let's look at the next one here real quick, and then we'll look at the output. All right, and then here's procedure 2. Procedure 2 does nothing more than what? Here's procedure 2, it just calls procedure 1. That's all it does. So I'm going to execute procedure 3, excuse me, that calls procedure 2, that's going to call procedure 1. Okay, of course you're going to have lots of other code in here, but this is just a demonstration for you real quick. Now when we get to procedure 1, it's going to actually run into a problem. So as you can see in here, and I just kind of hard-coded it for simplicity purposes here, but procedure 1 is going to raise an exception. I just threw in the no data found just to pick one. Okay? So when I raise that exception there, that's going to cause him to fall down to here, and then he'll execute this code out here. And I'm just going to do printing to the screen here in this case. You could write it to a file, you could insert it into a table, whatever you like. I'm just going to insert it to the screen, the result from calling the air stack. And I usually put them in this order because you'll see with the air stack, it's kind of a high level, doesn't give you a whole lot of information. Calling the program format air stack, a lot of you probably have used this. There's a function called SQL error message, SQL ERRM. Calling the format air stack is basically the same thing. Okay, however, if you call the SQL ERRM, it's going to return the error message, but it also returns that in a certain number of bytes, 255 characters. So it will truncate longer messages if you call the SQL ERRM, whereas the format air stack will not. Okay, the format air backtrace, that's going to give us a little bit more detailed information. The biggest thing that the format air backtrace is going to give us is the actual line number that caused the error. Okay, that we're trying to track here. Now we could also get the line number if what? we ran our program with no exception handling, right? But we really need exception handling in our programs. We need it to be robust. We need it to be thorough. We need to capture stuff. If we run our programs with no error handling, it'll run. It'll tell us the error message, but we're not getting as much information as we possibly could. And then the call stack will give us the trail. What program called what program, until we get to the point of the error. So what we're going to do here is, remember, procedure 1 is going to raise the error or the exception, and we're going to start this whole thing off by just executing procedure 3, which calls procedure 2, which calls procedure 1, which then fails. Okay, now if we look at the output of what we see here, here's our 3 problems here, 3 pieces of code that's going to give us our output. If we look at that, here's what we end up with. Okay, so the first one up here at the top, this is the result of the format error stack. Okay, that's the format error stack. All you get is the Oracle error number and the no data found. Again, that's just like running the SQL ERRM function. I just get that. You can also run what? The SQL code function and get the error number, like a 1403 or 100 or whatever corresponds to that. Okay, so that's the first one. That's the format error stack gives you this. The second one here, this is the result of the format error backtrace. So it tells me exactly what program I'm in. Yeah, that's a problem with this one at the top, right? No data found, but it didn't tell me what program that was in. That's the problem with that one. So if you got programs calling programs, that's what causes that issue there. So the second one is very helpful. It tells me what program I was in and at what line number. And again, you can get this one if you just run your program with no error handling, which wouldn't be recommended. And then this big blob of information down here in the bottom, that's obviously the result of calling the format call stack. So you're going to read this from the bottom up here. So the anonymous block, that's what kicked off the whole thing, because when I kicked this off, I was just in SQL Plus, and I typed in execute proc3a. That's where it got kicked off. So that's where we ended up in here, and then on line 4 in proc3a, we called what? Proc2a, and on line 4 in proc2a, we called proc1a, and then in proc1a, it was line number 7 that caused this output to happen. That's not where the error was. Line 7 is the call to the format call stack, not where the error was. That's why I want this guy up here as well. I want the call to the format error backtrace to get the actual line where the error was. So the error was on line 4, but the call to produce this output for the call stack was on line 7. Okay, so in other words, line 4 raised the no data found, and then line 7 did the put line with the format call stack. Okay, so you can take this information. You don't have to display it to the screen. Again, you can write it to a file with the UTL_file package and the put line program within there. You could insert it into a log table or something like that as well. Okay, your choice is what you do there. Okay, now I will say that the format call stack, if you guys haven't run into it already, if you have programs calling programs, it can get a little bit, I don't know what quite the right word is here. I'm going to use the word flaky for lack of a better word. So for example, here I had procedure 3 called procedure 2 and procedure 2 called procedure 1. If I only put the error handling in procedure 1 and not in 2 and 3, my call stack would only show me the anonymous block, and it would only show me procedure 1. It would not show me that I was actually in procedure 3 and in procedure 2. That could be misleading. So if you're going to do the call stack, if you get to a point of maybe you don't have it in your programs at least initially, but you're going to add it later on, when it's time to kind of troubleshoot or debug your program, make sure you add the call stack to each of the potentially programs that could be called. That way, because that keeps the trail going. Otherwise, he loses track of the trail, and he could give you some misleading information there. And if you go out and Google that, you'll see all kinds of examples of people saying the same thing as well. So that's why I had it in each of my exception sections there. It doesn't hurt to put it there, right? All right, so here we looked at 3 different programs there. Now there was one other program within this package that we wanted to take a look at. Let's look at it real quick and then we'll start to wrap stuff up. And that was the get time or the get CPU time. And I use this one a lot too. And in fact, I was just working with somebody at a client site the other day, and they had a large program that had many steps in it, but they weren't sure which step was the problem. So we're going to run it through the profiler for one thing, but also what you can do is surround each of the steps with calls to get time as well. So for example, here I just have a comment right here. It says, you know, put the code to measure or the procedure or function call goes here. So if you've got maybe a select statement or an update or a call to procedure that you think has taken a great amount of time, but you're not sure how much time it's taken, you could do this. Right before that code, just put in a call to get time, save it in a variable. Right after the code, do a call to get time, save it in a variable, and then do what? Subtract the two, one from the other, to get the total time. This is in hundredths of a second. And then throughout your program, do the same thing. Now, of course, you could just do the profiler and get the same results, right? But maybe the profiler hasn't been set up, or you don't have access to do that or whatever, then you could do this instead. Okay, so I'll do this. So I had that person go out there. We did it both ways. We put in some get times just in case. We did and ran it through the profiler, and then that pointed out exactly which piece of code, because he wasn't real sure. Is it the delete? Is it the refresh? Is it the select the new source code? You know, where is the problem? The program's taken 4 hours to run, but I don't know where the problem is. So you could use this. You could use the profiler like we saw before, or just gather the times here. Just make sure, you know, one particular time doesn't tell you anything. That just says, you know, this is in hundredths of a second. Get the next one that's hundredths in a second, then you're going to have to do the subtraction to get the difference between the two. Okay. So we looked at the DBMS profiler. We looked at the start profiler, the end profiler, or stop profiler, I should say. And we saw the steps that were necessary to do that. We saw that there was 3 tables, basically. That's it, 3 tables with the profiler that we can go out and query, and they don't have very many columns, so they're very easy to query and such. And then we looked at the DBMS utility package as well. Okay, hopefully that'll give you a little bit more information to kind of go out and gather some additional information on how to make your PL/SQL programs a little bit more robust and a little bit more thorough when it comes to tracking performance issues and tracking where problems are occurring in your program, especially if you've got a series of programs, which a lot of us do. So we're not always just running one program. We've got programs, calling functions, whatever out there. But down the road there, if you've got any questions about things that we've talked about, feel free to send me an email at jmullins@themisinc.com as well. All right, a couple things just to wrap up here is also, so hopefully those things that we went through there you found to be useful and helpful to you. Again, we've got some other classes, in particular this troubleshooting, debugging, and tuning. PL/SQL programs is a great class. It goes into great detail. It's a 2-day class, so it's not too much of your week. It goes into great detail. This is just a subset of what that class goes into. And then there's other PL/SQL and SQL classes you can go look at as well. I just want to mention too that we do our next free webinar has to do with DB2 type people. So this looks like an exciting one. This is titled Developer Best Practices for DB2 Performance. And that'll be occurring on Thursday, December 17th. So a lot of you will be getting an email with a notice of that, or you can just go out to themisinc.com/webinars and see some information about that too. That'll be presented by Tony Andrews, which many of you have either taken a class from before or one of his previous webinars also. All right, for further information on some of the topics we talked about today, you can just go out to themisinc.com and see a list of all the courses and services that Themis offers. You can contact John Cacavel of Themis there, and you see his email address. jcac@themisinc.com, and a phone number you can reach him at. Remember, my name again is John Mullins, and I recognize a lot of you from previous classes. So again, it was great seeing you, some of you here today again. And again, remember, you can get copies of the slides at themisinc.com/webinars, and then a little bit later on, give us a day or so, go back out and check. You could get actually a recording of today's webinar as well at that same website. Okay. Thank you, everybody, for attending today. Appreciate it very much. Hopefully your week's been going great, and your weekend will be even better. Hopefully the information we talked about will be helpful to you. Again, if you need further information, send me an email at jmullins@themisinc.com or visit some of our websites for more information. Everybody have a good day, and hopefully I'll be seeing you soon.